You might have heard of the concept of programming. You might even have tried to write some code. It sounds so cool, but the concept of programming is actually nothing different than telling a computer to do some operations in a sequence. But how does it actually work? Well, the short answer is, the code we write is total gibberish to computers. Also, depending on the code you write, it might also be gibberish to other people.
Whoa. Roasted.
We use high-level programming languages like Java, Python, or C. Yes, C is a high-level language. To write code that we can understand, which includes keywords that make sense to us but are meaningless to computers, like if-else statements or int, char for variable types. Then, the high-level code we wrote is translated into codes that computers can understand, which is also known as machine code. This translation is done by compiler, which itself is another program also written by humans. Compiler goes through phases like lexical analysis, parsing, semantic analysis, optimization, and finally code generation. Okay, that's enough information for the short answer. Now, the longer answer. Let's start with the basics. A computer can only understand two states, on and off. What we call computers are actually a collection of many on-off switches which are called transistors. All these on-off switches are packed in a very small chip nowadays which we call a processor. Each of these transistors can be either on or off at any given time. Binary code represents the state of a transistor with ones and zeros. Typically, 1 means on and 0 means off. Each state of a transistor is called a bit. These bits are grouped in 8, which are called bytes. Fun fact, computers also use these on-off switches or transistors, if you would like, to remember stuff as well. But that's the topic of another video. But the thing is, modern computers include up to billions of transistors. If you want to write a code in pure binary, you better have some time. In most cases, you have to check the state of every single transistor, which would probably take a few lifetimes, even for a simple hello world code. Maybe in that case, your children can take over the quest. To prevent this problem, where writing a code would take a few generations, humans have come up with a better idea. That is programming languages. Earliest implementations were punch cards, which worked as an interface between humans and machines. Punch cards had holes on them, which can represent either 0 or 1. These were given to computers so that they can read the zeros and ones and do what they were asked for accordingly. Basically, they represented some instructions for computers to follow, which works the same way as programming languages. Computers did very basic stuff back then compared to what we use them for today. What we call programming languages are nothing other than a set of syntax rules that define how the code should be written and formatted. For example, in Python, indentations are important for the compiler to understand the scope, whereas in C++, the indentation makes no difference. Also, programming languages determine how the written code should be translated into binary code. That means each language works in a different way to turn your written code into machine code. Programming languages can also differ in the levels. A higher level language will be much more similar to our written language with many abstractions, whereas a lower level language would be closer to machine code, which is harder to understand for humans. High level languages take care of a lot of stuff in the background for the programmer. It sounds good, but this way the code might use more resources than it actually needs. So you might end up with an inefficient code. So if a language is closer to machine code or is lower level, the programmer has more control over the resources that the code uses. But this also comes with a lot of responsibility where the programmer should deal with a lot of stuff like memory management, garbage collection, etc. But how do you run a code anyway? It depends on the programming languages you're using, but the overall process looks like this. Your code is translated into assembly language. Depending on the language, this may be done with an interpreter, where your program is translated line by line, which Python does to translate your code, or with a compiler, where the program is translated as a whole, which C++ does. This way, another code file is created in the process. What this file is, according to ChatGPT, an intermediate binary file created by the compiler after translating the C++ source code into machine code, but before linking it with any other necessary object files or libraries. The coding language then sends off the assembly code to the computer's assembler, which converts it into machine language that the computer can understand and execute directly as binary code. At the end of this process, you can see the message printed by your computer on the screen. If you stick so far, congratulations. Now you know the basics of programming as much as I do. You might want to check out an academic reference though. Don't believe everything you see or hear on the internet. But you might still want to like, subscribe and share this video. Thanks for watching.